Welcome to Tomorrow, Orbit 12.18. See, I remembered. I thought you knew I would forget. I'm Carrie Ann Higginbotham. I'm going to be your host today. And with me, of course, is Lisa Stojanovsky. And before we get started into our exact interview this morning, we have a little bit of announcement. Miss Lisa, if you wouldn't mind taking it away.
Okay, so if you haven't seen the Apollo 11 film that came out on DVD, Blu-ray this week, I recommend you go see it. It is a fantastic documentary on the mission that we landed for the first time on the moon. Never before seen footage. It's really cool, and it's so cool that we've actually partnered with them to do a giveaway for everyone watching right now. So from now until the 28th of May, so 10 days, if you go on Twitter or Facebook and you take a picture of the moon, go outside, take a picture. Maybe for some reason you can't go outside where you live, that's fine. You can do an artwork of the moon, take a photo of it, post it on Twitter or Facebook, use the hashtag #KeepLookingUp, all one word, and tag Tomorrow, and then you can be in the running to win a telescope or a director-signed lithograph or a theatrical poster. It's really, really cool. I'm really excited. So,
I mean, look how pretty this is.
Yeah, it's awesome. So it ends midnight on the 28th of May. You get one entry each, and
midnight Pacific time.
Pacific time, yeah.
Just to be clear.
Pacific Daylight Time, to be clear as well. I probably should have done it at UTC time now that I'm thinking about it, but it's fine. Yeah, so super excited, and it is US only. So if you're not in the US, we're really, really sorry. This is the first time we're doing one of these sweepstakes things, so this is gonna like dip our toe in the water, and then the more experience we get, we're gonna kind of do more worldwide giveaways. So super excited.
Yeah, super excited. That's going to be a lot of fun. Very cool. So please go out, do that. Take some pictures, draw some things, all of the fun things, paint some things, be creative. Maybe like make a picture of the moon out of moon pies, for instance. But yeah, do that. Hashtag don't look up. Hashtag tomorrow. Keep looking up. Sorry. Don't look up. Why would it be like that? Never mind. Nervous. I haven't been on camera in a while. In any case, to get started, our guest today is Dr. Cameron Smith, who is the co-founder of Pacific Spaceflight, which is interesting because for his day job, he's an archaeologist. He works at Portland State University's Department of Anthropology. He's written a number of books. So really, that begs the question, being on a show like Tomorrow, Dr. Cameron, why are you building spacesuits?
Well, I think that's a very natural question, right? I study human prehistory and evolution, and so that's looking into the past, right?
Right.
Well, the past is a story of adaptation. The past is human dispersal globally across the planet. In the last 100,000 years, modern humans dispersed into every imaginable environment across the globe. And they did that by adaptation. They adapted to their environments by technology. And I think it's a completely natural progression to continue that beyond the surface of the Earth. Why would that stop at the surface of the Earth? So I'm interested in ancient and modern technologies. Here, for example, is a piece of ancient technology, right? Used to adapt to places, to conditions worldwide. A stone projectile, or actually a stone armature that goes onto a lance or something like that. And this allows you to survive in environments where our otherwise fragile body couldn't survive. So we've been using technology to survive in places where the body couldn't otherwise survive for hundreds of thousands of years. I think it's perfectly natural continuation of that, to go to space.
So can you tell us a little bit about, you decided that space is the next kind of frontier that humans are going to use and use technology to be able to enable us to get there. So you've made this decision that it's important for us to use technology to expand our human potential. And to be in space, we need spacesuits because otherwise we're going to die. So how do you go from, cool, we need spacesuits to progress humanity, to I'm going to be in my garage and start building a spacesuit?
That's not a normal thing for normal people. And I don't want to sound offensive, but archaeologist doesn't necessarily sound like you have an engineering background. So that's quite the leap in logic for many people, if you could explain that.
Sure. Well, when we think of space technologies, of course, we think of high technology or space suits,
Sure.
for example. But I'll go into sort of why I decided to actually take on this technical challenge in a bit. But I also thought, how can you possibly do this? And then I started looking at the history of pressurized garments and space garments. And I saw that actually the first ones were not built by people who had an engineering background. They were built for flying to 50,000 feet, for example, pressure suits, built for flying to 50,000 feet. And they knew that they needed to perform a certain number of functions: maintain temperature, exhaust the CO2, deliver oxygen, maintain pressure, that sort of thing. And built very simple garments that worked. And today we would call them uncomfortable and difficult to use and all of that. That's less important to me than the fact that it worked. It got people to 50,000 feet and back down in good health. So I saw that if they could do that in the 1930s for pioneering aviators to explore the jet stream, for example, and we all use that today, right? If you go on an airliner, you're using something that came from people using early pressure suits. If they were able to do that in the 1930s with rubberized silk and leather parts sometimes and very simple metal fittings, I thought, well, maybe I can do something like that today. So the reason that I had confidence in my ability to do it was that I read extensively. I did a lot of background research into the history of these things, and that's where I started that track, of thinking, yeah, this is reasonable.
And what did the first suit that you made kind of look like? Was it heavy? Was it bulky?
Well, I think I call it the Frankenstein suit because it was so scary, and sometimes I would inflate it, and to pressure test it, I would leave it inflated overnight, and it would be standing in in my apartment in the corner. It's just standing there, this big, crazy-looking thing, and I'd lay there in bed at night looking at it. It was very creepy. The first generations really looked utilitarian. They were built for function. I didn't give any thought to the look. I never thought anybody would see them. I just thought, I'm going to build this to fly my balloon to high altitudes. I want the adventure of high altitude flight. I don't care what it looks like. I care if it functions. So everything was for function.
Sure.
Recently, for a number of reasons, we've started to think about the outward appearance a little bit. One reason is that if it looks really crazy, people won't believe in it. And so even if it has really good function. So it has to meet some visual expectations. I've been learning that, for it to be accepted, there are certain things you need to do to make it look like what people expect a little bit. So the first ones looked very DIY, and now they're looking a bit more like what one expects.
You're very DIY in general. I watched as many videos of you speaking as I could find and muster. I was up a little bit late last night. So I think one of my favorites was your TEDx talk in Portland, where you brought on a couple of the suits, some of the first generation suits. And you're up to like a Mark 7 now. Is that right? Am I?
Actually, yeah. Online, I haven't even shown many of them, but there's I think 1 through 7 are online, but I've just finished a number 10, Mark 10.
Oh my goodness!
And there are 2 sizes right now of the Mark 10. One is for a person on the order of 6 feet tall, and one is for a person on the order of 5 feet tall. And they're resizable, but we are going towards a range of sizes so that any number of people of different sizes and shapes can come and fly with us.
That's amazing. You just made Lisa very happy.
I'm really quite short. If I stand up, I'm probably not even as tall as the TV. But so barely 5 foot. So that's exciting for me to know that that's kind of, I guess, your goal is to make space accessible by making spacesuits for everyone of different sizes. We had that controversy on the International Space Station where they didn't have the correct size suits. And that, allowed a person to not be able to do a spacewalk because of that. So why is it important to you that, we make these spacesuits in different sizes and I guess maybe reduce the cost of making spacesuits as well? Like, what are those kind of ultimate values and goals that drive why you're doing this?
Well, it's a little bit philosophical because the real cost of space access is propulsion. It's the rocketry. Um, Now of course, they can improve that, but it's still a few $1,000s per pound to get, material, anything to space, to orbit, let's say, to LEO. You need a few $1,000s per pound. Well, if we can knock a basic launch entry suit from 70 pounds, which was what they were wearing in the shuttle, to 8 pounds or 10 pounds, well, that's a big savings right there. You're saving over 50 flights per year, for example, of multiple crews. Now you can start to save, some tens of millions of dollars yearly just in boosting spacesuits to orbit, or millions of dollars. And some might say, well, that's just a drop in the bucket with regard to, the larger costs of space access. And yes, maybe it is, but if you can start to drop all of those costs down, then it starts to make a difference. So right now, I'm not under the illusion that this allows a lot of people to go into space. This is a small piece of a big, big puzzle. The larger project, the ultimate thing, is to show that the first piece, the most basic piece of exploration equipment required for adapting to places beyond Earth is not what I describe as the holy relic. For a long time we've seen these, and they cost millions of dollars, and they can only be touched by a technician from a certain company. All of that, I think, can be thrown away. What I'm looking for my paradigm is the Toyota pickup truck of spacesuits. Cheap, durable, reliable, effective. Maybe we shouldn't say a brand name, but basically the old farm truck.
Sure.
The pickup that you use it for utility. That's been one of my technological objectives. Can I get everything down to nothing more complex than what is under the hood of a maybe 1980s era pickup truck? So simplifying, making them lighter so that they're a bit cheaper, and then getting designs out there such that other people can improve on the design. That's also a big part of the goal.
Mm-hmm. Awesome. If I remember correctly, you're looking at no more than is it like 11 pounds and $1,000 per suit?
Yes, the 11 pounds is pretty easy to get. And again, this is a suit that gets you to orbit and back, right? It's a launch entry garment worn inside the spacecraft. In case the spacecraft loses pressure, this keeps you alive. Mm-hmm. This is not the suit for outside, for floating around and building or working on the space station, or what's coming now, of course, which will be space hotels and that kind of thing.
Totally.
So this is for inside the spacecraft. Mm-hmm. But yes, we can absolutely put that at 11 pounds. And the materials cost, yes, something like $1,000. We're approaching that. It's the labor, it's the time and the expertise that's required to assemble those materials into a functional garment. That would be the expense, but the materials cost is down to $1,000 roughly, and the weight is not the problem. Weight is pretty easy.
That's amazing. One of the questions, kind of to Lisa's point a little bit, one of the questions coming in to us from our chat room, from St. Alex, saying, apart from the size, is there differences for different genders?
We haven't explored it too much. Maybe 1/3 to 1/2 of the people who have worn our suits in my workshop, working at home and helping to build them and design them and also test them out. Maybe 1/3 to 1/2 have been women, and right now we haven't tailored them close enough or thought about that enough for it to be any kind of a difference. We might learn more about that as we make more of these. But for the moment, no, there hasn't been a significant difference, aside from, generally speaking, in stature, in any measurement, height, arm breadth, whatever. Generally speaking, in in human evolution so far, we've had about a 10% what's called sexual dimorphism, difference in the general size of the two biological sexes, male and female. And right now, that's about 10% difference in size. But, that's not universal. We have a person interested in coming, and she's to wear one of these, and she's 6 feet tall. She's 6'1", taller than I am. So that's a general rule. It's not universal.
That's interesting. So I think I know where you're going to go with this answer based off of, like I said, some of the talks that I watched you give. But coming from YouTube chat room, Raj Lutha is saying, what is a spacesuit made from, and can it be used in multiple environments? If you wouldn't mind explaining that a little bit, answering that question, but also maybe touching on a little bit of how you got to some of the conclusions you made based off of not just that you had read some of the schematics of some of the earlier spacesuits, but I happen to know that you like to also dive and you hang glide, and you have spent 4 expeditions in Iceland, and you've done quite a bit in order to sort of make those what I consider to be leaps in logic. But as you tell that story, it seems very logical to me. I followed that, if you wouldn't mind with that.
Sure. Yeah, it was in Iceland on an ice cap expedition that I thought, I need I could really use a totally protective garment out here. There it is. And, I was wearing a coverall there, but it was really, this is a very nice day that you're seeing there. On not very nice days, which was most of the time, very windy, 40-mile-an-hour wind, just wet slush, so it's right around freezing, so wet slush and spray caking onto the side of my face. And I thought I need a dome helmet and a visor, and I just thought it would be good to have a sort of a spacesuit. And that was around 2003, and that was when I started really thinking that I could, on those expeditions, I was kind of exploring environments that were kind of like, well, I can't go to the moon, they're not doing that. I can't go to Mars. So I can find those places kind of on Earth and explore and get something of the sensation of that on Earth.
Totally.
And then when I was there, so that's why I was there. And then when I was there, I started thinking again about the possibilities of contributing somehow to human space access and space exploration by designing these garments. Because I had relied on clothing like that to keep me alive a lot. And I'd always modified everything I ever wore for Arctic expeditions. I modified it. I'd snip off pieces of it or put on a loop that I needed to make it even just a little better. And I thought, okay, I can apply that maybe to some kind of high altitude, garment to fly a balloon to extreme altitudes, and that led to the spacesuits. What else? What other environments could they be used for? They could be used in the Arctic, in the Antarctic. Here's a great challenge. Nobody's yet walked to the South Pole in winter. Many expeditions have gone in the summer, but in winter it's about 100 below before wind chill. And even the Norwegians, who are the greatest of the polar explorers, even they will hardly venture from their hut in the Antarctic winter. What about an expedition walking to the South Pole just for the adventure and just for the incredible experience, wearing garments derived from space exploration? I think that would be tremendous, and I'd love to do it myself, but I'm tied up right now with these things. But we've worn these underwater for, you do these immersion tests, and we do them for many reasons. Psychologically, they're good. To get the team working as with using hand signals, for example, if our communications go down. It also is a good test of the suit. It doesn't leak, that sort of thing. So we've used them underwater. We've used them in cold chambers, but they could be improved for that. We've used them for flying. So there are a lot of, there's in the cold chamber, and that was about minus 22. Subsequently, we've gone to about minus 50. And so there are all kinds of applications for them, or for the technology, I should say. But I haven't really explored that. I've really focused on exploring the tech for this is what I'm really wanting to do, is the adventure of high-altitude flight.
Fantastic. I love the attitude that you said when you were doing Arctic expeditions, you would modify and make your garments better and just explore and just be curious, always trying to improve. So how do you take that attitude and apply it to the current issues that we have with spacesuits? For example, we have a question from the chat room from Travis Neal on YouTube who asked, it seems the biggest two issues with suits are the hands and the face. So do you have any unique insights to these issues and how we can improve them?
Yes, the holy grail right now of spacesuit design is mobility at pressure. Everybody knows who works on these things, everybody knows how to make a gas-tight garment and flow gas into it and then exhaust gas out of it and not have leaks, that sort of thing. The difficulty is, do you have mobility, dexterity, for example, in the gloves? Do you have arm rotation? What's the range of mobility when the suit is pressurized? And the suits that I've built so far are for launch to orbit and then return. And what you're expected to do there is literally be strapped in. And if something goes wrong, you might reach for a switch or a knob or a button, but largely it's automatic systems take over, at least with the Soyuz. And not much is required, right, of those suits. Those aren't for high mobility. But of course, like anyone else, we're interested also in, can we develop a Mars exploration suit for the surface of, where we're most likely to go soon, Mars, I think. And so we're working on that, but it's a whole new ballgame. So mobility. So far, mobility in, for example, the shoulders is achieved mechanically. There are what are called bearings, and there are a set of roller ball bearings in these circular mounts that give you rotation. I'm hoping that we can get away from those. They have liabilities. They can wear out. They're expensive. They're precision type engineering required to make those. And I've got a couple of ideas on how we might be able to avoid using those, but still get mobility. But you can bet that every spacesuit lab that's trying to make a breakthrough in spacesuits right now, it's in mobility at pressure.
Totally.
Now, there is one exciting alternative. Professor Dava Newman at MIT, she's been working for 15 or so years on the biosuit concept, which is not a suit that inflates with gas, but a suit that compresses around you like a wetsuit and does the job that the gas bubble, high-pressure gas bubble does, but just by compression. This, however, is very difficult to achieve in the engineering sense, and so she's still working on it. It also requires some advanced materials and so forth that I'm not conversant with. So I'm sticking with the simpler gas pressure suit, but there is a whole philosophy of design with a compression suit, but it's still being explored.
That's fascinating. That's really, really cool.
That's what you see when in the movies they have really nice tight-fitting suits that makes everybody look really great.
Yes.
That's kind of the idea of the compression suit. One of the problems with it, though, for example, is that it really has to be sized exactly for the one person. Those are not very resizable. So I think there will be all variety of suits, and so just like we have all kinds of vehicles. So we have pickup trucks for doing, labor and moving things around. But if you want to go out and have a nice time, maybe you have a sailboat, right, or a different kind of vehicle. So I think that, when people inevitably do sports on Mars, the Olympics or something on the surface of Mars, they'll have really cool, beautiful skin suits. But people who are building the sewers and everything, or building the orbital hotels and everything, they need industrial clothing. So I think there's a future both for gas pressure suits and mechanical pressure suits.
I think you've raised a really good point about how, especially with the mechanical suits, they need to be individualized. But going back to gas pressure suits, one of the problems we have today is the fact that there are only it's hard to make the suits perfect for everyone. So do you think there's a better way that we can come up with, ways to size the suits and how they can kind of be interchangeable? There's a question from the chat room here, and it's scrolled up too fast, so I can't read the name, but it's the one about vehicles and spacesuits. I think it's from YouTube, and they ask, why not make spacesuits more like vehicles that anyone can use rather than suits that few can use?
Yes, that's what I'm trying to do. We're even trying to simplify their use, and reduce the amount of training that you need to use them. With regard to the, I'm sorry, I forgot the first part of the question. So one part was, what about the making them easier to use? Yes, we're working on that.
And the sizing.
Oh, yes,
so
modularity. Can they be made for resizing? They can be made modular, where you have a shoulder part and then an upper arm part and a lower arm part and then a glove. And for a longer arm, you switch these parts out, or or torsos, different sizes. However, that gets very expensive, because you have a lot of different joins, and each of those joins now becomes really critical. It's a place where it could leak, where otherwise, if there's no join there, it's not going to leak. And so that becomes expensive. Depending on the kind of suits that we're talking about, it might very well be that once you have a pattern, so I've learned that making these garments, you require patterns. And there's a geometry of lines, which in flat textiles, if you cut it, and then of course you apply it to human body, it fills out and gives you 3 dimensions. Okay, applying that concept, you might be able to come to a set of patterns that are so well formulated that the measurements that a person sends you just go straight into a machine. It cuts the patterns, assembles the suit, and makes it a lot cheaper. So
that would be amazing.
That can happen. It'll be cheaper. It'll be simpler. And I don't think you'll need that modularity. I think we'll be able to, for some suits, we'll be able to achieve lower cost, but broader variety of suits for people by better patterns and a better manufacture process. But that's all sort of out of my realm. Again, I'm pretty practical with trying to demonstrate that these suits work. I have a long way to go with that. Many people think that this is, not really viable. So I need to prove that these work.
Yeah, I think you touched on another really important point here of, testing these and making sure that they do what they're supposed to do. So you've talked about using them in a cold room. Are there any other tests that you guys have done to kind of show that these suits do what they're intended to do, and they're safe? So, if you're wearing them in a capsule, they're not going to be too bulky. I believe you guys have partnered with Copenhagen Suborbitals. Can you tell us a little bit about any tests you've done with those guys?
Yes, with CS back in 2013, we went over there, and it was just so exciting to go into the capsule that Christian von Bengtson was designing, and we worked with Christian for a few days, just in some very basic things. Can we get in with the suit on? Can we get out in an emergency situation with the suit inflated, and for some reason you need to escape the capsule? Also, it was just meeting. We just wanted to meet and talk and see if we're on the sort of same page. Oh, yeah, there we are with my buddy John Hazlitt.
Awesome.
And running the camera is a CS person named Morton. And so, that's the mock-up of their capsule. And this is all exactly what NASA and precursors of NASA did back in the old days. And so what we did with them was start a series of tests. So we went, in fact, in Copenhagen, we went into an altitude chamber, and subsequently we started flying helicopters and different kinds of aircraft to higher and higher altitudes. And the reason to fly and not just go into an altitude chamber is a very controlled place, but you want to fly in real conditions, right? There's a point at which you go out of the simulator and you start flying real aircraft for all kinds of reasons.
Totally.
And so we will do both. We'll continue. We're using our balloon now to fly to high altitudes, because a balloon is a very cheap, relatively safe way to get to high altitudes. NASA and precursors of NASA also used balloon to get to 100,000 feet. Well, that's 100% vacuum there. They got to 100,000+ feet back in the 60s. In fact, the day before Alan Shepard went up as the first American into space, the day before he went up, 2 Navy pilots, I believe one was Navy anyway, went in a balloon to 110 or 120,000 feet wearing exact replicas of the suit that Alan Shepard was going to wear the next day.
That's awesome.
And they did that because they knew this is a great way to test it. And yes, they could do that in a chamber, but everything is different if you're doing a real flying operation, right? You want to test in real conditions. So we're going to be flying our balloon to higher and higher altitudes using the natural world as our altitude chamber.
I love it.
We will also, though, to really prove it to everyone, we are working on getting access to a vacuum chamber so people can see the suit worn in a vacuum. So we're working on all of those. I'm emphasizing flight and real conditions. The one thing that they can't do in the altitude chamber is they don't pump the temperature down to minus 70 or minus 100 Fahrenheit.
Oh, yeah.
Which is what you get at 50 or 60,000 feet. So that's a real major engineering consideration that you really need to have operating, to show that the suit, again, is working, is minus 100 Fahrenheit. And they don't do that in these altitude chambers.
Totally. So you keep saying we, and so you've got a whole team. You have a whole team behind you. Like, this used to be just you, kind of in your, as Lisa put it, in your garage or in your apartment, for the most part. But you've got a whole team working towards these goals. At least one would hope that you do. Like, I hope that you're not going up in a balloon by yourself to 50,000 feet, in negative, all those temperatures. That's crazy pants. So if you wouldn't mind telling us a little bit about your team, like how you've assembled this, and yeah, what your next goal is, which I believe is coming up at the end of this summer, if I remember correctly.
Oh, I'm awfully lucky. We have a group of people, and we just gave ourselves a name, Pacific Spaceflight. When we came back from Copenhagen Suborbitals, we thought, well, this is, they're not crazy. We're not crazy. This looks like a real thing to do. So we need a name. And we came up with something similar, a region. We love the region, the Pacific. And then we said spaceflight, generally speaking. But it's not a company, even though our website says PacificSpaceflight.com. That was just a convention when we bought the website. We should change it to org or something. But it's not a company. It's just me and some friends and volunteers who've decided they heard about the thing, and almost everybody, I think everybody just came by emailing me and saying, hey, I'd like to, come and help out.
That's awesome.
And many people have come and worked on parts of things for a few weeks or months or even years, and then moved away. Of course, it's a long project. Right now, it's about 4 of us that are really active, but there are about 30 people on the email list, and it's been a little while. I've had to work by myself for a little while the last few weeks for a couple of technical reasons. But many times the way that it works is I send out a bulletin at the beginning of the week, and I say, here are the days of the week that the doors will be open from, say, 6 to 9 or 7 to 10 p.m., something like that. Come on over and work on whatever. And then whoever can make it will come over and assemble parts of it. So it's been a big collaboration. I've had some good ideas, but many of the ideas that make these things work have come from other people who've come through, and I just had the time to implement them, right? They've said, well, what if you think about doing it this way? And then they had to go off and, continue life and whatever. But because this is all I do, I thought, I'll implement that.
Yeah.
And so, yes, there's one object, and when the cameras come around and, they want to see what's happening, they tend to focus on me. But there's a big team, and they have a lot of great ideas, brilliant ideas sometimes that have really helped us move forward.
So you mentioned that one of your goals for your team later in the year is to achieve this higher altitude flight, but are there any other up-and-coming things that your team is working on that you're going to be introducing? I know that you have a new program that I'm actually really excited to maybe try myself, a kind of spaceflight training and experience program. Could you tell us a little bit about that coming up in the fall?
Yes, 2 things. Very exciting. So just now we're preparing to go to the Paris Air Show. We were invited to go there and display our suits at the Paris Air Show, which is one of the oldest and largest in the world.
Yeah, it's cool.
And we're going to be in the Hall Concorde, right underneath a Concorde sitting there, our little booth, Pacific Spaceflight. And, right down the way, there'll be Grumman. And if I don't think Grumman exists, but, there'll be Boeing and all those. So it's going to be very hard to imagine. So we'll do that in Paris in middle of June. But then in August, yes, we're running our first spaceflight training course, and this is basically learning the operation and use of pressurized suits. And these are spaceflight suits. These are our training garments. If you go to our Twitter, you can see one. I just posted a picture of one today or a couple days ago. These are our training garments that we've been using for years, but now we have built them to train people to the standards that the FAA requires for commercial spaceflight activities. So the FAA has a number of requirements. If you're going to go on commercial spaceflight, here are the things you need to know how to do. Survival at sea, egress from a spacecraft, how to deal with smoke and fire hazards, that sort of thing. We have a professional firefighter as one of the instructors, Kim Cunningham. She instructs Coast Guard, in fact. She trains Coast Guard trainers
Awesome.
on some of these techniques. And then we have Trent Tresh, who has undergone his own commercial spaceflight training course at Embry-Riddle Aeronautical University in Florida. And then, of course, I'm providing the suits and the technology and the 10 years of being pressurized in these suits. So the three of us together have come up with this 4-day training course that gives the participant the basic set of techniques to wear one of these, feel comfortable wearing these, and be able to handle the essential emergency procedures in commercialized spaceflight.
That sounds amazing.
Can we do it? I am so down.
We can write that off for tomorrow, right? Yeah. Okay, good. My director says yes, perfect.
Fantastic. Right now we have a 4-day course set up for in August. And it does actually give one college credit through Western Colorado University.
Oh, that's awesome.
Anyway, we have one 4-day class set up right now, but we're also working on preparing a either 1-day or weekend course for people who just want to get a taste of wearing these suits. It's I call it a 5-sensory experience when you're wearing these. When it's pressurized, all 5 senses are engaged in something new.
Yeah.
So there are sounds inside the suit. There's gas coming in, gas going out. There may be pumps. There's a hissing sound. You have 2 ears, so we give ourselves 1 ear for the suit, what's going on in the suit. You want to hear popping, you want to hear creaking or other stuff. And then the other ear is for your intercom, talking to people outside. That's the whole world of radio communications. You have to be able to, be able to communicate clearly what you need. So speak on the radio. And then your body, of course, is going through pressure changes. So you might need to change pressure by yawning or chewing something like on an airliner. The odors are different. The pure oxygen coming in, boy, that's a nice odor. But then there are all kinds of odors of the materials used inside the suit.
Oh, yeah.
So all 5 senses are engaged in this thing. So some people just want to have that experience of, being taken to high pressure, strapped into the seat, taken to high pressure, and given sort of this simulation of this is roughly what it would be like to do the 10-minute flight to orbit and then back down to Earth.
Yeah, I'm personally afraid of heights. So yeah, if I could stay on the ground but still get all those sensations, that would be really ideal to me in pretty much every way. That sounds amazing. And just really quickly, because we do have an international audience, if I remember correctly, those courses and those availabilities are ITAR and EAR cleared. Is that correct? So anybody in the world who is willing to make the trek and pay the money to do all these fun things, that is an availability to them?
Yes, we've looked at that, and that is not a problem anymore. The pressure suit used to be, I believe, a defensive weapon, but I think just in the last few years that has been altered so that you can even transport them internationally. we're not trying to transport military ones internationally, and all of ours are simply inflatable suits built at home. So, and we don't use any military technology. So, no, that's all clear. And you can contact us, and anybody can contact us, and we can be absolutely positive that there's no problem with the country of origin and using things over here. So.
And
I think we're fine there.
That's awesome.
I will note that also there is a flight involved at the end of the 4-day program. There's a flight to 25,000 feet in a beautiful plane that we're using. And you are wearing the pressure suit, and it's about an hour-long experience where you fly to 25,000 feet. We stay there for a while, and then we come down. And you have 2 instructors on board, and we're observing you. And it's just like being in an altitude chamber. When they check you out for high altitude, they put you in a chamber to 25,000 feet and have you take your mask off and everything. But we're doing it in a real aircraft for the adventure of real flight.
Absolutely.
And to get out of the lab and into real conditions. Also, it's minus 30. And it's loud, the plane is shaking, and there's a huge door. The skydivers jump out at 18,000 feet, and we keep pushing up to 25. It's very exciting. And so I should mention that that's also part of that 4-day course.
Oh, that sounds incredible.
Wow. For those wondering, how much does that cost if you were to sign up for this course?
Say again, what was the cost?
What's the cost, yeah.
Yes, right now it's $4,000, so it's very expensive. We're going to start knocking the price down, but that's where we have to start. We'll have some kind of a less expensive one for the 1-day, of course, and weekend course, but right now it's $4,000. So, but it does cover, all you have to do is get here. It does cover your lodging, all meals except dinner. Your training, it covers the flight at the end of the project. It covers the training in the pool, using life rafts, the smoke and fire hazard training, and then pressurization, using the suit several times.
Awesome.
Right now, it's a little bit expensive. We understand that, but that's where we have to start to. But we'll start to knock the cost down.
Yeah, no, that's totally acceptable. Absolutely. There was a great question from Rebel in our chat room that says, what is your intent for these designs? Open source, licensing, setting up a company? Like, where ultimately are you going with this?
We're going in several different directions. We've built a couple of these for balloonists, for example, who want to go to high altitude, and right now those are under non-disclosure agreements. So they want to control their story, and I totally understand that.
Sure.
But we've done that in a way that if somebody were to be hurt in one of these, I wouldn't want my Pacific Spaceflight folks to be legally jeopardized. So this year I will create a company where I'll build some of these garments for people who say, I'd like to give you some money to build something for me to do a flying expedition. Mm-hmm. And that will be a legal barrier so that, any problems that come from that just come to me, and my friends in Pacific Spaceflight can't be harmed.
Yeah.
Does that make sense?
Yeah. Oh, yeah, absolutely.
Yeah. So Pacific Spaceflight will always just be the fun think tank of friends doing cool things with pressurized garments.
Sure.
But then there will be my company for legal protections. Mm-hmm. We also do need to do things. For example, our flying course, or our spaceflight participant course that I just mentioned, that's required for us to keep our project going. We have a balloon, and to fly it in the summer out in the desert is a great expedition. We're out there for a week or 10 days, and we're flying in remote areas. But it's very expensive. I have to fuel the balloon every day. I pay to make sure that everybody's comfortable, so I make sure I cover everybody's travel and food costs. And we have a lot of field equipment costs.
Sure.
So to fund our own project, right, to fund our flying program, we're working on ways to bring in a bit of income.
Yeah, no, that
and
makes
one
sense.
of the ways is that spaceflight training course.
Very cool. That actually coordinates really well with another question from our chat room from Sarge Enzyme. Have any organizations approached you? I can talk for these suits.
Yes, I will come to that. I'll just first mention also the last caller mentioned that there was a question about open source.
Oh, yes.
Yes, I do. I do want to put the essential plans for the basic IVA suit, intravehicular access, the one to orbit and back. The essential plans for how to make these online, open source. I've been wanting to do that for a few years, and the only reason we haven't done it yet is, well, we've been busy trying to get them to where we want them technologically, which is where we are now. But I want to control the process a bit. I didn't want to just leak out, here's how to do this part, here's how to do this part.
Sure.
There are good reasons, I think, to put it all into one package. Well, now that I have started thinking about that again, that needs a nice website, really good instructional videos, and a book, basically, a manual.
Yeah.
So we need somebody, I can't do all of that. So we would need somebody who wants to produce that would have to come and do it. But that's definitely been a big part of the philosophy for a long time, has been to open source the general design such that other people can then come and improve on it, right? Make copies of these things, but make them even better.
Totally.
And I did notice that, that second question, who has approached us? Many individuals and companies have approached us for various reasons. Most of them, when we engage with them, I'm not allowed to talk about. I signed non-disclosure agreements.
Sure.
And it's kind of a funny world where I kind of understand it. If they fail, or if their project fizzles away, they don't want it to be known that their project really didn't go off the ground. Right. I understand that. So yes, we have had a tremendous number of contacts and connections, but none of them really are substantial. Right now, there is no substantial. We don't have substantial. We don't have contracts that where we're building suits for any company or anything like that.
Totally.
We might, but in the future. But right now, we don't. And if we were to do that, it would not be Pacific Spaceflight. That would be my own little separate company.
Totally.
So Pacific Spaceflight will always be as open source. If you go back through our Twitter, you can see a lot of the technology being assembled there. I just haven't had, and so I'm not hiding it, but I just haven't had time to package it properly so that it's comprehensible and people can actually copy doing it. That's going to take a lot of work.
So you talked about having Pacific Spaceflight be sustainable in terms of having the money and funds you need to go and do these expeditions, and then having the people and the time and the resources and skills to be able to keep that going. So you mentioned that you're doing the training course as a way to raise the funds, and that you do need people that have time and skills to set up training videos for suits and make nice websites and things. So first of all, I like spacesuits and I like making videos, so maybe we can come to some kind of agreement there. That'd be cool. But if you had people out here watching right now, how can they help, whether they have money or whether they have time and skills and the willingness to volunteer and help out Pacific Spaceflight? How can they help you guys to be sustainable and successful?
Well, first off, thank you for offering. That's a wonderful thing for you to suggest. The best way is to email me, and we'll see what you have, what somebody has that they might want to donate. We have needed a truck for a long time. We need an old pickup truck for our field expeditions. So, I think the best thing is if somebody wants to help, if somebody wants to participate, we love to have visitors. We've had people come from all over the world arrive here. We've had people from Holland, of course. We've gone overseas. So we love to have visitors. So you could come here, but the first thing is just send me an email and say what do you propose? What can we do that would be good for you and that would be good for us as well? We don't have a formal system. We've tried I think 5 times to do a sort of Kickstarter or some kind of crowdfunding. Well, it turns out that's a very big project, as anyone who's done it knows. It's a very big project. And also I noticed, I did a lot of research on that. I think about 6 other projects trying to do high altitude flying of one kind or another have tried crowdfunding, and it didn't work. And I didn't want to be number 7. So we haven't really set up a system for accepting donations and so on.
Sure.
So I think the best thing would just be contact me. You'll find me on just Cameron Smith spacesuit or something like that. If you just Google that a little bit, you'll find my website and email. Or you can go to our website, pacificspaceflight.com, or just go to Twitter and look for Pacific Spaceflight, and that links to a place where you'll find an email to reach us. And we'd be thrilled. I'll be thrilled to have anyone contact us, and let's do something together. Let's see what we can do that would be useful for you as well.
Absolutely. Well, there's also T-shirts on your store as well, which I got really excited
I want
about.
a T-shirt.
So yeah, we're definitely buying some T-shirts at the very, very least. Dr. Cameron Smith, welcome to the TMRO family, by the way, as we are good friends with Copenhagen Suborbitals for sure. I'm sure you've heard of Tim Dodd, the everyday astronaut, as well. We'll see if we can get you guys kind of connected. I feel like there's some synergy there. But we definitely want to keep in touch and keep up to date on all the different projects. You know, once you guys actually kind of get flying, and I mean, I know you have been flying, but like, so once some of these other projects really get kickstarted, we definitely want to help out and participate and keep updated on all of those things, because I'm super excited. Like I said, yeah, I'm afraid of heights. I will stay on the ground, but some of the pressure testing stuff sounds really cool.
We need ground people. Oh boy, our crew, we need ground crew, and we'll be flying in the most beautiful deserts in remote southeastern Oregon and northwest Nevada this summer, in late August and September. We
cool.
welcome crew to come out. There's hot springs. We soak every night. And
that I'm also willing to do. That sounds amazing. You're definitely selling this.
Beautiful camping. It's beautiful camping. And during the day, the balloon is flying, and we're chasing it with the truck with binoculars. We go and pick it up. So we need field crew, and just email us, and we'd love to put you onto the field crew team.
Perfect.
Great.
Dr. Cameron Smith, thank you so much for joining us today and explaining how an archaeologist gets to the skies. I thought that was really, really cool. Really appreciate your time.
Thank you. Thank you for having me. Yes, it starts with this, right? It's the same thing.
That's amazing.
This may as well be spacesuit technology. It's technology to adapt.
Perfect.
Fantastic.
All about adaptation.
Thank you very much for having me.
Absolutely. Thank you so much.
And before we go, we also want to give a very big thank you to the people that actually make shows like this possible. We could not do this show without you, so a big thank you to our Escape Velocity citizens who contribute $10 or more per episode. We also have our orbital citizens, suborbital citizens, and our ground support. Your funds make us able to sit here and do this in addition to our day jobs, and to speak to these amazing people. They give me the opportunity to work for TMRO full-time and get people like Cameron on the show. And so without you, this wouldn't simply exist. Now, if you can't contribute financially, at patreon.com/TMRO or subscribestar.com/TMRO, you can always contribute your time, your resources, any skills you might have at community.tmro.tv. That's our show today. Thank you again for watching, and we'll see you next week.